Hello everyone, hope you all are doing well. So I'm back with another Leetcode Daily Challenge and it is Leetcode number 847, shortest path visiting all nodes. It is a hard level question, but I somehow feel it is a medium and medium to hard, not that much hard. Okay, so the question is you are given an undirected graph which is also connected graph, okay, and the nodes are from 0 to n minus 1, it is labeled, okay, and you need to find out the shortest path which need to visit, okay, all the nodes, okay. You can travel through a h as many time as you want, okay. Like if you see this example number one here, this h02 will be traveled two time, okay, and you can visit again a node any number of time you want, okay, but you have to return that how many time you are how many edges you are traveling. Like for this example, if it is you go through one, then zero, then again over two, then again zero, then again three, okay, so it is four. So you have to return like this, and for this example it will be again four, okay. You can see that diagram here, and the constant are quite small. The constant is n can go up to 12, okay, means in the graph there are at max 12 elements, and as and graph I does not contain I, and graph A contain B, and graph B again contain A, so the input graph is always connected, okay. So let's go through an example and let me draw this graph, okay. So it is like 0, 1, 2, and it is 3, okay. So first thing, uh which you may notice, like we need to find out the shortest path. Now if it is the shortest path, then what we can use, as I told you earlier, we need to do a BFS, okay. Whenever you found a shortest path, you need to do a BFS. Now there are certain ways in which you can do BFS, like simple BFS or extra. Now what we require here, the edge is unweighted edges, okay. So you need not to use a Dextra, so you can implement the direct BFS, okay. And so we will try same thing, we will do it BFS, okay. Now here the catch is the node can means the starting point can be any of the node, okay. It may be the first zeroth node or one or two or three, okay. You can see here for this example the answer start from one, then you go to zero, then two, then zero, then three, okay. And for this example it starts from zero, okay. And for the different examples it can be any sort of means what I say, any node is the starting point, okay. It can be any node. So so we have to check all the possibility of every node, okay. Means we have to start from zero, then again one, then two, then three. So we have to do the same thing, okay. So basically the first point is we have to do BFS for every node, okay. BFS for every node, okay. Sec- okay, so we have to try the BFS of every node, okay. So you need just this is the observation you need to take care. As I told you this question is not that much hard. Even I also get my correct submission on the one go itself, okay. So when you are checking and you are as you are doing a BFS, whenever you find out, like if my all the node are as all the node are visited, okay. Whenever you find out my all node are visited, the simple return the depth, okay. The depth or the depth of the BFS, okay. All node visit, then visited, then simply return answer. For example, I go 1, then 0, then again 2, then again 2 to 0, then again 3. And at this moment of time, my all the nodes get visited. So I finally return my depth, which is come out to be 1, 2, 3, 4. So I just return 4. Okay. So it will be very much clear when I show you the code. Okay. So let's see how the code works. Okay. Means we have to take care of this 2 point only, and nothing else. And all the other thing I will explain you parallelly. Okay. So First of all, you can see here the constant is quite small, so I have taken a mask, okay, to keep track of element. And or else you can try to take a vector also, or means a state, any kind of array or vector or something. But I have taken a mask, okay, because it is easy to handle a mask, okay. So you can use a vector also. So I have taken a mask and I set my all the elements to 1. Like after this code processing, my binary representation of the marks value is something like 1 1 1 1, okay. All the four node, all the four are becomes now 1, okay. So it is my original marks. Now what I do, I just created a queue as I told you, and I just store the marks value and my current node value, okay, in the queue, because we need to travel, okay, for all the pair. So we need to keep track of the current pair. Like if I start from 0, then what is the marks? If I start from 1, then what is the marks? So okay. So you have to keep track of this all thing. So I've taken here pair of intent, then I have taken an another set of string to keep track if my all or if my this node is already visited or not, okay. For example, if you are visiting, okay, if you are visiting this 2, okay, and 0 and 1 is already visited, okay. So then you visit the 2, and again if you try to visit the same thing again after visiting, order may be different, but 0 and 1 is already visited, so the marks value will remain same, okay. How? Because the element which element I am visiting, and I mark that element as 1, okay. For example, if you see here, I just push all the node inside my queue with the node number, and I create a new mask, okay, of that size. Like whenever it is 0, the 1 will be shifted to 0, so it will remain 1, okay, like 1. Now when I push 1 here, so it will be the 1 will shifted one time, so it will be 1 0, okay. For 2 it will be 1 0 0, for 3 it is 1 0 0. Then whenever I perform this, it will update this mask, okay. Now, I just take a string. This is only for to keep track of if my current data set is visited or not. Visited or not. Okay. According to my requirement, means it should match the means that node also and the marks value also. Then only it will keep means it will tell us like it is visited. Already you have visited that node at same amount of that marks element. Okay. So I am converting this into a string simply. Then I just put it inside the my set, okay. Now I have taken the path variable which will keep track of my depth or the path. Here we need to find out path, so I rename it as path. You can write here as depth also, okay. The code is same, simple BFS code it is. Now the queue, okay, till the queue gets empty, we just simply need to process. Then I take out the size of my current queue. I just process that complete queue, okay, of that size. I take out the node, I take out the mask, then I pop the element from the queue. Then I check if my current mask is equals to marks, okay. Now here, when your current marks, okay, is equal to marks, means yeah, the original marks is what it is, all nodes are enable, okay. For this example, there are 4 nodes, so on this will look like something 1 1 1 1, okay. The binary representation of this marks. Now when your current marks also represent like 1 1 1 1, okay. So it means that you have visited all the node, okay. So simply return the path, whatever your current path is, okay. What just simply return it from here. Otherwise what we have to do, otherwise we just iterate over all its adjacent elements, okay. And I enable my mask variable, okay. Like for example, if I first is I come here for this, if I start from 1, so my this current marks will look like something like 1 0, okay. Now what happened, I come to 0, okay. Then I enable the 2 to the power 0th element. So this is the 2 to the power 0 element, which is it is 0, so I enable it, so it is 1 1, okay. So the new marks will be something look like this, okay. Now I just put this inside our set, and make a string and just check if it is already present or not. If it is present, then we have checked this permutation here, so we will not check this again. Okay, so if it is 0, then it is not present in the set. This count variable will return how many time it is present in the set. Okay, so it is 0 and it is not present, so I just simply push it into the queue for processing further, and I just insert it inside the set. Okay, then it will completely process itself, and at a point it will get something, current marks is equals to marks, so it is directly return your answer. And okay, so I hope this is the code, and as I told you, it is not that much hard question, and if you know BFS and a bit of bit masking, it will work fine. Just you need, okay, if you don't know bit masking, just simply do what, just simply try to convert this marks into a vector. Okay, vector of integer you can take of n size. Okay, and initially mark all element as false. Okay, and you can try that also, it will also work. Okay, but you, as you know, if you want to check if all your element are in the vector is marked as true or not, then you have to travel all the element. But here so it will take of n time, which is here it is 12, so it will take of 12 time. And for this question, it will not give you TLE, but in certain questions like a bit hard question, it will give you TLE. To encounter like such stuff, we use a mask. Okay, and we just enable and disable the binary representation. Okay, so I hope you understand, and let me submit this code. Okay, you can see here I just got in one go. Okay, so it is submitted and accepted, and I will provide this code in the description. You can check it out there, and I hope you understand this question. So so I will see you tomorrow.